Okay, thank you. So component B is making actual real-time or near real-time forecasts. Okay, so for CMIP 5, lots of groups developed the climate prediction capability. This was to initialize their climate models with observations. Lots of key experiments were done into trying to assess the skill of these. But what about actually making real-time predictions? This is what we really need to do. This is what people really need to know. What's going to happen in the coming few years to a decade? Okay. And this was recognized by the WMO, who recommended that we start to coordinate an exchange of all of these decadal forecasts that were being made by the various centers that had developed this capability. So this informal exchange started in 2011. We get roughly about 9 dynamical systems participating and 2 empirical. And at the moment, we're just exchanging fairly basic variables. So these are annual mean fields of surface temperature, pressure, and precipitation. We've also managed to get quite a few groups to now send in predictions of the Atlantic overturning circulation. We're aiming to exchange these fields in March every year. We haven't quite achieved that deadline yet, but we're working towards it. And so here's the kind of current status of this activity. Here's all the various groups and their submissions so far. So I would say a massive thank you to everyone here in this room that has contributed to this exercise and continues to contribute to it. I think it's a really important thing to do. So we have, as I say, quite a few international groups doing this thing every year. We have a web page for this activity. You can go to this address at the bottom there and have a look at it if you like, and you can see the forecasts for various variables for temperature, pressure, rainfall from the different centres and the average of all of these, and for the forecasts that have happened in the past, and we now have observations, you can have a look at how well or badly they did against those observations. Okay, so I think one of the kind of criticisms of the Decadal Prediction Project is there's a misperception that there isn't any skill. So I've heard that in some quarters. And this is something that we really need to push back against, because there definitely is skill in decadal predictions, okay. That there's skill coming from the climate change signal, even on these short timescales of a year or 2 years or years 2 to 6, 5 to 9. And this is shown by this plot here, which shows the correlation predicting the number of extreme temperature events in a given period. So even on these short timescales, the climate change signal does give us skill, okay. But there's skill beyond that in these decadal predictions. Initialization is improving the skill. And you can see that from these plots. So the left-hand column is for globally average temperature. And you can see the red solid line is the initialized predictions. The red dashed line is the uninitialized predictions. And then the kind of gray bars are the observations. You can see that the initialized predictions are much closer to the observations, and that's reflected in the lower RMS error in the bottom left panel. And that's for globally average temperature. But what people really want to know is what about regional predictions? And one measure of that is the Atlantic Ocean sea surface temperature, the so-called Atlantic multi-decadal variability. And there the improvement in initialization is even clearer. And you can see the red solid line clearly matches the grey bars much better than the dashed uninitialized prediction. So there's definitely skill in the North Atlantic coming from initialization, improved skill. And is there a physical reason for this improved skill? Well, I mean, a lot of studies have linked the strength of the overturning circulation to the SSTs in the Atlantic Ocean. And it's been shown by quite a few of these kind of perfect model type experiments where we try to predict the model's own evolution, that one of the things that's the most predictable on these decadal timescales is the strength of this overturning circulation. Of course, it wasn't measured very well in historical periods, so we're kind of relying, if we want to assess whether these models can actually predict the strength of the overturning circulation, we're relying on some sort of synthesis of the observations to kind of take in the temperature and salinity data that we have and convert that into overturning circulation. And that's what this plot here shows. At the top left shows several different analyses of these observations, which are very noisy, it's true to say, but there is a kind of common signal where there's an increase up until the mid-1990s and then a decrease thereafter. And you can see that the initialized hindcasts at the bottom left do capture that signal reasonably well, not perfectly. There are still plenty of things that need improving, but they do sort of capture that signal. Whereas the uninitialized ones on the bottom right really don't have that signal. They have, if anything, just the opposite signal of a decreasing trend in the overturning circulation. So that improvement in the North Atlantic SST that we're seeing, I think, is backed up by this physical, as far as we can tell at least, by physical improvements in the dynamics of the climate system. And does the North Atlantic matter? Well, lots of studies have demonstrated potentially important links between North Atlantic temperatures and important climate impacts. So if you look at a time series of smooth North Atlantic sea surface temperatures, the top left panel there, you can see there's clear decadal timescale variability in that. And if you look at associated time series for Sahel rainfall, India rainfall, and hurricane frequency, you can see a strong coincidence, if you like, between the SSTs in the North Atlantic and these climate impact time series. And if you make a composite of in the observations of all the times when the North Atlantic is warm minus all the times when it's cold, this is what the right-hand column shows. You can see potential signals for temperature, pressure, and rainfall. You can see signatures over the US and the African Sahel and even Europe, kind of hinting that there could be important climate impacts that maybe we could predict associated with this predictability in the North Atlantic Ocean.
Excuse me, are those deep trended?
Yes. Yeah.
So maybe it's all forced rather than...
Well, this is variability around the trend. So the North Atlantic SST time series is detrended. So around that trend, there's periods of relative cooling, relative warming.
But if you have the trend in, it looks a lot like a global average temperature change.
It does. I'm not saying anything about what's causing this variability around the trend. That's a whole different and very contentious issue.
Look at it separately from the trend.
Okay. So.
Yeah. Yeah. So, and right now, I think I would say that there are potentially very important changes going on in the North Atlantic Ocean. So, as I said, we didn't measure the strength of the overturning circulation in the historical period, but we have measured it since 2004. And this shows a fairly remarkable time series, actually, where there's actually been about a 30% decrease in the strength of this overturning circulation in that 10-year period. And that is potentially a huge signal. I'm not saying it's collapsing, but that is a sort of rate of decline that would be consistent with a collapse. And we really need to understand what's causing that, whether it's going to continue declining or whether it's going to turn around and start increasing again. And it's also seen in other indices, so there's like a density index that John came up with, and you can see a clear, very sharp decline in that density index too. So what I'm arguing is that right now, the one region where we think we can predict with our best skill, the North Atlantic, is showing massive changes potentially in the climate system, and we would expect to see large impacts associated with that. And indeed, our decadal predictions, the ones we make at the Met Office, and quite a few other ones actually, are showing a continued cooling in the North Atlantic. So the top left panel shows the North Atlantic temperature time series. We have the observations in the red and blue, and we have our hindcasts in the bars, and then the very latest ones where I think the symbol changes to a cross. Because that's what it, anyway. These are real-time forecasts that we've been making, and you can see that every one we make is showing a cooling relative to the previous year. And that's connected to a change in the density. So the top right panel shows this density index, so that's reducing. And I mentioned some of the impacts that are associated, potentially associated with changes in North Atlantic temperature. One of those is Atlantic tropical storms or hurricanes. And at least with our forecast system, we're predicting a reduction in the number of hurricanes, but there are many other potential climate impacts that could be associated with that, including changes in Sahel rainfall and the risk of drought in the southwest US, winters and summers in Europe. There are plenty of things that we need to understand much better. So decadal predictions are skillful. We really need to push back on this misperception that there's no skill in decadal predictions. There's a signal from the trends, from the climate change signal, but there's also significant improvement from initialization, especially in the North Atlantic, as a physical basis for that, and improved predictions of the overturning circulation. And there are potentially large important climate impacts, including tropical storms and rainfall in many regions around the Atlantic basin. Right now, the Atlantic overturning circulation that we measure appears to be weakening quite substantially, and we really need to focus on this and predict whether this will continue or whether it's going swap around. And we've had this informal exchange of decadal predictions going back since 2011, which is a great start, but we really can't rely on this. It's just an informal thing. It relies on people just, their goodwill to submit these forecasts. So we need a formalization of this exchange under the WMO to support the global framework for climate services. There's already a structure for such a thing for seasonal forecasts, and I think what we're aiming to do is to kind of copy that structure for the decadal climate forecast and have this thing as a proper WMO-supported activity. And of course, to do that, we need forecasts themselves, which is the DCCP component B. So,
any questions?
Just a comment along the lines of what you said. The WMO Congress is discussing precisely this issue this week in Geneva. So the support from several countries.
Yeah, it's gaining support. It's good.
Yeah, just from another historical perspective, before I acknowledge Steve, but this kind of informal collection of decadal predictions done by groups, kind of look to see how they do. It's kind of mirrors what was happening 30 years ago with the ENSO prediction community. We were talking about this at the Mark Keynes Symposium when Mark Keynes, Debiak, and these other people in the 80s were using visualized models, and they're seeing maybe they're getting some skill for ENSO prediction. So this is kind of an interesting something that's happening very similar in a similar way 30 years later. So decadal predictions kind of coming along 30 years after ENSO predictions. Steve?
Is there an indication for multi-model scale is greater?
So that's one thing that we will need when we make this a more formal process. We will need a better assessment of the skill of this multi-model ensemble, which we don't have to a great degree at the moment. So there are some assessments of the models that were put into the CMIP5 archive. Some of those are not the same as the actual ones that have been running right now. But in that sense, I think there's a fairly robust signal that there is improved skill in the North Atlantic. I think that's the main conclusion from that.
Shane Pin was next.
Yeah, maybe just follow Jerry's comment about seasonal prediction. So I saw the first success of seasonal prediction was based on a simplified model, Xavier Capital. So you kind of initialize the answer model and suppress some other noise. I'm just wondering if a similar approach can be considered to initialize some. If A mark is maybe there's a way you can initialize A mark and suppress other noise. I have no idea. I just
It's definitely something that's worth a look at, and indeed we do have these empirical predictions as well, which is something sort of along those lines, which provide an important benchmark for the dynamical systems to try to aim at and exceed if possible.
So Alicia and then George.
I have so many comments, but one of them was, now that you said that, what is the performance of the statistical relative to the that you've seen?
I don't think there's been a full assessment yet on that. From some of the work that has been done, I think the statistical models do provide a good level of skill, but I think the dynamic ones, maybe John can correct me on some of this, but I think some of the dynamic ones do provide more skill in this North Atlantic region. Is that true, John?
Yeah, that's true from Ed Hawkins'
Yeah.
work so there's skill for very short lead times in the North Atlantic, but the statistical model can't predict this with such high levels of skill beyond a couple of years. So it's just the persistence, I think.
Yeah.
So maybe last question from Jordan.
Doug, this formalizing under WMO is presumably a good, but is the state of the science ready for it yet? And what is the time scale for this formalization?
Well, I'm arguing that the state of the science definitely is ready. We do have skill from these decadal predictions. I mean, this exercise has been going on for seasonal forecasts, and not all of that is particularly skillful, but the seasonal forecasts have ENSO and maybe some more skill now, and decadal forecasts we have the North Atlantic and associated climate impact. So there is a need for that. There's big changes going on. This is the right time to do it, and the time scale really was in the next couple of years to try and get this properly supported by the WMO and operating properly.
Okay, Christoph, why don't you come up when we start the transition? And then while he's coming up, Alicia has another follow-up here.
About the state of the art thing, the thing is that in some ways, if it's not state of the art right now, it's the right time to start. because what you want to be able to show 20 years from now is that the science has evolved.
Yeah.
You can't show that unless you've archived the forecasts.
Yeah, absolutely.
And retrospective forecasts are not the same as real-time forecasts.
They're
as we
not,
know.
indeed.
You really have to have a strong